Hey guys, welcome to Calculus Daily, Excellence Edition 2. We're looking at 3 excellence questions from 2013. Okay, so looking at the first question here, this is all that's been given for the question in algebra. If u equals 6 plus ki, v equals 4 plus ki, find k if argument of u times v is pi over 4. So we're actually looking for what k is. So the first step we want to do is we want to actually try and figure out what u times v is going to equal. So what is u times v? Now remember that u times v, that little dot there is just another form of writing multiplication. So if I was to work out uv, I'm going to have u, which is 6 plus ki multiplied by 4 plus ki, and expanding this, I'm going to have 24 plus 6ki plus 4ki plus k squared I squared. So simplifying this, I have 24 plus 10ki plus k squared times -1. So my uv then is equal to 24 plus 10ki, not plus, minus k squared. Okay, so this is what u times v is going to equal. Now, the next thing that you need to look at is this pi over 4. So for a complex number to have an argument of pi over 4, let me just show you guys what pi over 4 looks like, just that on a complex plane. So if we take our normal complex plane, there's our real and imaginary. Now if a complex number has pi over 4 as an angle, it's going to look like this, pi over 4. But pi over 4 in degrees, and I think looking at degrees it might make a little bit more sense for you guys. Pi over 4 is 45 degrees. Alright, so if you have 45 degrees as the argument, then you're actually looking at I'm just going to try and draw this, an almost like an isosceles triangle there. So which means the x part, the real part, and the imaginary part should actually be equal for you to have an argument of 45 degrees. Which means I need to go back to my complex number uv, which is this, and I need to say that the real part is going to equal the imaginary part. Only then the argument is going to be 45 degrees. So if I look at the real part, 24 is real and k squared is real. All right, and the imaginary part, I'm just going to write in a different color. Let's see, imaginary part is going to be this one here. So if I was to write uv again, I'm just going to write it up as the real parts first, which is the green bits here, which is 24 minus k squared, plus, and the imaginary part is 10ki. Okay, so if the real part equals imaginary, then what I could then say is 24 minus k squared is then equal to 10k. So this makes an argument, which will give you an argument or the angle of 45 degrees. So once I have this, what I need to do is I need to solve this to figure out what k is. So I've got 24 minus k squared equals 10k. Rearranging this, I'm going to get k squared plus 10k minus 24, and simplifying this as a quadratic, I have k plus 12 and k minus 2. Therefore, k is equal to -12 or +2. So now I've actually got two values for k. It's really important that you actually substitute k back in there and to see whether they actually work out. So for example, where's my simplest format? So what I'm going to do is I'm going to substitute k equals -12 first in uv and see whether it actually works out. So because u times v equals 24 minus k squared plus 10ki, when I substitute k in here, I'm going to get 24 minus -12 squared plus 10 times negative 12i. Now this gives me a solution of, I'm just going to simplify this real quickly, guys. So I've got 24 minus 144 minus 120i. Simplifying this, I'm going to get 120 minus 120 minus 120i. So if I was to draw this complex number, I know I'm running a bit short on space. If I was to draw this complex number, minus 120, let me just put that here, minus 120 and negative 120i, that complex number is going to be, okay, that's minus 120, that's minus 120. So this complex number is going to look something like this. And as you can see, the argument for this is not 45 degrees, but it's actually 135. So, well, sorry, not 135, 180 plus 45, which is 235. So the argument in this case for UV is actually 235 degrees. Okay, and that's not what we wanted. We wanted an argument of UV to be 45 degrees. So let's try when k equals to 2. So if we try k equals to 2 and then do UV, we have 24 minus k squared plus 10ki. Okay, substituting your k. So you have 2 squared plus 10 times 2 times I. What we have is 24 minus 4 plus 20i, which equals 20 plus 20i. Now, if I was to plot this one, so 20 will be here, 20 will be here, and then if this is the complex number, and as you can see, right now this is 45 degrees because the x part and the y part is the same. So therefore, the only value for k where argument of UV equals 45, so k is actually equal to 2 and not minus 12. So it won't actually work for minus 12. Okay, and that's what you need to do for this question for an excellence. So in terms of grades, I think you need to actually prove that k is equal to 2. And having that logical chain of reasoning means you get an excellence. 2 correct solutions for k from quadratic equation gets you a merit. So if you get up to here, you're looking at a merit. And for the achieved, you're just looking at the expanded expression of UV, which is basically right there. Cool, that's it for this question. We'll go to the differentiation question next, guys. Alright guys, for this question we've got a closed cylindrical tank to have a surface area of 20. Find the radius so that it has, so the volume, tank needs to have the, so that the volume it can hold as large as possible. Okay, so basically we've got a cylindrical tank. Alright, we have the surface area of the tank is equal to 20. So that's the first thing I'm going to do. I'm going to actually work out an equation for this 20. Now surface area of a cylinder is 2 pi r squared. So let me just put that up. Surface area is 2 pi r squared h plus 2 pi r h. Okay, so from this point I need to actually say that, well, because the surface area is equal to 20, I can say 20 is equal to 2 pi r squared plus 2 pi r h. Now if you look at the volume of a cylinder, volume of a cylinder can be written as volume is equal to pi r squared times h. So obviously I want to differentiate the volume function, but I can't because of that h. So I need to get rid of the h and replace it with something else. Well, ideally I want to replace it with r so that I can actually differentiate volume. So to do that I have to go back to my surface area, which is the blue equations here. So I need to rearrange everything so h is by itself. So I have 20 minus 2 pi r squared equals 2 pi r h. Therefore h is equal to 20 minus 2 pi r squared over 2 pi r. Simplifying this, I have 20 over 2 pi r minus 2 pi r squared over 2 pi r equals h. So h then equals 10 over pi r minus r. So once I have this, in my volume function now, I could actually replace h, because I have h in terms of r now. So I can say volume then equals pi r squared multiplied by 10 over pi r minus r, because that's what h is equal to. So from here, I expand. So I have volume is equal to 10 pi r squared divided by pi r minus pi times r cubed. Simplifying my volume function, I have 10r minus pi r cubed. So this is what my function of the volume is going to be in terms of r. So now I need to differentiate this. And I think just looking at what the schedule is saying, if you can get up to here, equation of volumes and differentiate it. No, you still got to differentiate. So I got to differentiate this. So if volume is equal to 10r minus pi r cubed, then volume dash is equal to 10 minus 3 pi r squared. Now to find maximum, I need to prove that, well, I don't need to prove it. I know that it equals to 0. So that's when, so I can say that max, let's just say max or min happens when b dash equals to 0. So 0 equals 10 minus 3 pi r squared. Rearranging it, I have 3 pi r squared equals 10. R squared equals 10 over 3 pi. And therefore r is equal to plus or minus 1 point, what do I got here? 1.03? 1.03. But obviously we're not going to take the minus radius, so radius is equal to 1.03 meters. Now it doesn't actually ask you, it does say, I mean, if you guys read here, it actually says you do not have to prove that the solution gives the maximum volume. So this is how you do this question. Yeah, so it's not, I think, of all the excellence questions, this is probably a lot easier in differentiation compared to some of the ones I've seen. It's just writing an equation and then substituting it into, I guess, the second equation in this case, which is volume, differentiate, and then equal to 0. So standard stuff. Okay, so where do we get excellence and merits? We've got excellence right at the end there if you get the radius. And for a merit, it looks like you need to have equation for volume in terms of one variable and differentiate it correctly. So we're looking at somewhere here. And by the looks of it, there's no grades that's been allocated for achieved here. Cool, that's it for this question, guys. Off we go to the next one. All right, guys, this is the integration question from 2013, yeah? Now, I'm sorry, I won't be able to actually fit this in one slide because it's just a lot of things we actually need to do for this particular question. So what I'm going to do is I'm going to list down all the things we need to do and then see if we can start working through it. So looking at this question, I mean, the obvious part is they're asking us to find the shaded region. Now, to find the shaded region, we need, these are the things that we're going to need. All right, first, we're going to need the equation of the curve. So the curve has y equals f of x. So first, we need to find out what f of x is. So this is f of x. That's the first thing we need to do. Second, we actually need, I'm going to call this g of x, which is the straight line. So I need to find out the equation of the straight line, g of x. Third, I need to figure out is, what I need to figure out is the limits. So basically, I need to figure out what this point and this point is. So that's what my the limits are for the definite integrals. So that's the two intersection points. That's what I need to find out. And 4, which is the final part, fourth is the actual question itself, which is area. I'm just going to use a different color there, guys, just a bit, can't see it. So fourth is actually looking at the area. So 4 things we actually need to do in this question. I won't be able to fit it in here, but I'm going to try anyway. Let's try. Okay, so the first part I'm going to do is I'm going to figure out f of x. Okay, now for f of x, I've actually been given that f dash of x is equal to 1 minus 1/3 x squared. So if I integrate this, I get f of x is equal to x minus 1/3 x cubed over 3 plus c. So f of x is equal to x minus x cubed over 9 plus c. So I need to figure out what the c value is first, and so I definitely need a point. Now I've got a couple of choices for point, but I'm gonna look at what the question actually says, because in the question it actually says which passes through the origin, which means this equation goes through 0, 0. If it goes through 0, 0, then I can actually straight away say that c is going to equal to 0. Okay, if you don't believe it, let's see, I'm going to try and work in this area. So if the because it goes through origin, which is 0, 0, I can say that 0 is equal to 0 minus 0 cubed over 9 plus c. Therefore, c is equal to 0, which means I have f of x, which is x minus x cubed over 9. Okay, that's the first thing. The next thing I need to figure out is g of x, which is the tangent. Okay, so the first part is done. So to figure out the tangent, the equation of the tangent, I need the gradient and I need an x and a y value. All right, so the first thing I'm going to do is I'm going to work from the point they've actually given us, which is this here. So they said x equals -1. So this is I'm doing the second part now, which is working the g of x. Okay, trying to figure out what that equation is. So what do I know about this? I know that x at that point is equal to -1. So I need the y value and I need a gradient to construct an equation. So I'm going to work out what the y value is. So f of x from my previous equation from the top there, it's x minus x cubed over 9, which means f of -1 equals -1 minus -1 cubed, -1 cubed over 9, which equals -1 minus -1 over 9. So simplifying this, I have -8 over 9. So this is what f of -1 is. Okay, the next part I need to do is I need to find out what the gradient is at this point. So I've got f dash of -1, but I already have the gradient function, which is this right here. So it's just a matter of substituting. I have 1 minus 1/3 x squared, which equals 1 minus 1/3 -1 squared. Simplifying this, I have a gradient of 2/3. Okay, like I said, I'm going to try and fit this in. Most likely I won't, but I'll give it a go anyway. All right, so we've got for g of x to construct g of x, we needed an x value, which we have, which is -1. We needed a y value, which is -8 over 9, and we needed the gradient itself. The gradient is 2/3. So from here, equation of a line, y minus y1 equals m times x minus x1. Substituting all my values, so I have y minus -8 over 9 equals 2/3 times x minus x1, which equals -1. Simplifying this, I have y plus 8 over 9 equals 2x over 3. That's plus 1, so plus 2 over 3. And that's what I have so far. Rearranging this, y equals 2/3 x plus 2/3 minus 8 over 9. Simplifying this, I have 2/3 x plus 2 over 3 can be written as 6 over 9 minus 8 over 9, which means y is equal to 2/3 x minus 2 over 9. All right, guys, so I have my g of x, this is what my g of x is. Okay, so now I need to put g of x equal to f of x, which is here. Okay, when I put those two equal each other, I should get my two intersection points, which is those two green points that you see there. Right, like I said, I'm running out of space, so I've got to go to the next slide, so just bear with me in this one, all right? Okay, so continuing on from the last slide, we figured out what f of x is. F of x was, what did I have there? F of x was x minus x cubed over 9. And we also figured out what g of x was, which was 2/3 x minus 2 over 9. Okay, so from this point, we need to actually put them equal to each other to actually figure out what our two little intersection points are. So to do that, we just put both of the equations equal each other. So we have x minus x cubed over 9 equals 2/3 x minus 2 over 9. Now guys, like one of the things I'd recommend is just putting this on the graphics calculator and actually getting the 2 points out. But you know, if you want to actually learn how to do it the other way, just let's see what happens if we rearrange everything. Just realized something. Rearranging this is going to be a pain, and you're going to end up with a cubic and a... Yeah, I think the best, probably the best way to do it is put it in the graphics calculator. And if you put it in the graphics calculator, you should be able to find the two intersection points, which is x equals -1 and x equals to 2. Okay, so now that we actually have the 2 points, so we've got our 2 there and we've got our -1 there, now it's actually going to the part where we're actually going to find the area. Okay, so this is part 4 where we are finding the area, and sorry, that was part 3 where we had to find the intersection points. So to find the area, this is between 2 and -1. We had f of x, so the top minus bottom, and we can replace that with between 2 and -1. The top was f of x, which was x minus x cubed over 9, minus g of x, which is 2x over 3 minus 2 over 9 dx. Okay, so simplifying this equation before integrating it, we have x minus x cubed over 9 minus 2x over 3 plus 2 over 9 dx. Okay, now you can simplify it before integrating it. All right, it's up to you how you want to do it. I'm going to simplify it. So we got x minus 2/3 of x, that's going to be x over 3 minus, what else do we have? Hang on a minute. Minus x cubed over 9 plus 2 over 9 dx. Okay, so from this point, integrating it, I have x squared over 3 times 2 minus x to the power of 4 over 9 times 4 plus 2x over 9, and that's between 2 and -1. And substituting it and solving it, I should end up with an answer of, let's see, I should get an answer of 3 over 4 as my final area. Okay, so that's, I mean, it's a long question because there's a lot of things you needed to actually do in this. So to get an excellence, obviously you've got to get the area correct. And I think your merit is correct expression for area required could be difference of two integrals. So somewhere around here. And for achieved, I think for achieved you were looking at figuring out what g of x is, which is equation of the tangent. So that's what would get you an achieved. Cool. That's it for this session, guys. Thank you for watching.